Now today we will talk about how to model the geometry for the adsorption process. First, in the last lecture 11 or 12, I mentioned that how to model a geometry. So today, let's suppose I want to show you that how to take the structure. For example, let me take this geometry. Okay, so let me take this geometry, and this is the surface. Okay. So first we will show the bonding in between the atoms, and here you can see that this is the optimized geometry. Uh, this is the optimized geminal silica surface. Okay. This structure was initially modeled in the material structure in the material studio, and we take there is alpha cristobalite and beta cristobalite. So whatever you take, so we take one of that and optimize that geometry. But that geometry we terminated with the hydrogens at the surface. So let me show you in ball and stick, then you can easily understand. But for your understanding, the red color represents the oxygen, yellow is silicon, and white color is hydrogen basically. Okay? So we terminate this surface with hydrogen in order to uh, control its reactivity or the dangling bond. To remove the dangling bond effects, so we terminate the surface with the hydrogen. Okay. So now I will bring another molecule which I want to interact with this surface. Okay. Here, this is the critical molecule. Here again the same procedure. First we will monitor its bonding, and then I need to lift it up. So how in this case now you see that it is the structure is actually inverted, so I want to rotate it. Okay, so this is, so we rotated it by 180 degree. Okay, so now I will copy this structure, copy, and I will bring it here. So here you can see I will paste it here. Here you see that it is this way. Let me take that. So let's bring it to the center. So I will select this, and I will move it to the center. And then we need to check that whether it is at the center or not. So here you can see that it is not at the center. Okay, by simply you can guess that whether it is at the center or not. Okay, so now I will check it again that whether it is at the center or not. Okay, so first I will bring it to the near to the surface, and then because if you place it very far from the surface, then of course it will never come down to the surface to for interaction. So you normally we consider 3 angstrom above the surface. So in that case, there is no initial bond formation in the surface molecule, in the surface atoms, and the lower part of the molecule or another surface atom. So let me check. Okay, now I will check it like this way, that whether it is at the center or not. So you need to observe that whether it is at the center or not. So here you can check that whether this is complete circle or not. Then you can guess. So okay, I will show it here. Okay, now so you can see that this distance is basically a little bit smaller than this distance. So we can check that whether it is really smaller or it is in. Okay, so let me show you. So if we bring it closer, then we can see. So, that hydrogen, and this is the last one. Uh, that hydrogen, and this is the last one. So this is, you can see that this side it is 9.51 angstrom, and at the other side it is 10 point. So we need to move this a little bit the other side so that we can have equal distance. Okay, so here I will select this. Oh, okay, actually this is wrong. I select the wrong atoms, so I will remove this and this one, and yeah, so here this one, uh, here this. Okay, for our convenience, we can make this the surface uh, line and stick, and the molecule we will make it ball and stick so that we can easily. This, so this is these are lines. Okay, and the molecule I will make it bar and stick so that we can easily differentiate. So now we can see again. So here you can see that we need to molecule a little bit down, okay, so that it becomes it have an equal distance. So how to do that? I will rotate this way and then select the molecule. Okay, this I select the molecule and now I will move it to the other side. So here so this way you can move the molecule. Okay, now I will further reduce the distance and it's so here you can see. So further I will add 0 to this and now move it. You see? So now it is, oh sorry, I understand wrongly. I understand wrongly. This is 556 and that is 56. So this is now 551. Okay, 0 and now move this. So here again 0. You see, now it becomes it the molecule is now at the center of the surface. Okay, so here you can rotate. So from both sides, from all four sides, now this molecule is at the center of the surface. So this now I will export this molecule, export, and today is 23, 10, 20, 22. Okay? And I will save this in PDB format. Okay? So in order to verify this, I will check in different visualization software. And this is the Vista software, visualization software. Oh, here. Okay. So here you can see. This is the SiO2 Gminal I created now. So here you can see. So this is shared, okay? This one, and we can also we can zoom. Okay. So if we zoom it, you can see there's this surface selenol OH atoms and this surface selenol OH atom. The distance between the molecules is almost the same. Okay. So now you can export this structure to XYZ format and export data, and here you can convert it to any file format, whichever is easier for you. Okay, so do you want to save hidden items too? So I will say no, and let me check that how many number of items this system have. This is open with WordPad. So this system has 212. So I know this. The surface atoms are 198, and this molecule has 14 atoms. So this is 212. So the XYZ file is accurately created. Okay. So then after that, as we are using Siesta, or you can create it too. Let me show you. For example, I want to export this structure to VAS format. So VAS format, I will select Pascal and I will write here POSCAR. Otherwise, it will not save. Okay, so I am saving this file. Let's see. I will say Cartesian coordinates, and let me check here whether there is Cartesian coordinates or where is the open. Here is the open with WordPad and open. So here you can see. So this is the uh, VAS format input file, which is called Postcard. Okay. Here, in this case, there is no latest parameter. So you can put your the latest parameter of the structure which you create. So I know that which latest parameter because we already had the latest parameter file. Okay. So let me show you here. Here you can see it creates basically two files. One is the XYZ file and the other is the .xtl file. XTL file is basically the with cell boundaries or the PVC. So here you can see. So I can put the latest parameter values in the postcard file. Sorry, I collect the latest parameter here. So A is 14.75322, B is 14.97935, and because we create vacuum along the Z or the surface normal direction in order to have its interaction with molecule. Okay, so here you can see if I rotate it. So this Z is basically this face towards us or outside of the screen is the Z direction. So when I rotate it, here you can see this is the Z direction. Okay, let me zoom it out here. So you can have molecule for the surface. So if I apply the bond monitoring, then you will see the surface. Okay? So I can do it here also, but mostly the people, if you uh, take the surface from the bulk and create, so you at that time you cannot put the molecule directly. So for that reason, XYZ is simple to um, bring it to the visualization software. Okay, so this is all about age. If I place the latest parameter there, so I can create the postcard file. So now I know latest parameter. So the rest is diagonal 111. So here you can place the latest parameter values. Okay. Thank you very much.